All right, so this week we did some review of polynomial operations, specifically multiplication and division. And this video is going to focus on the division because that is something that is a little bit more involved and something that we don't do as often. All right, and there's two different algorithms we can use for polynomial division. The first one is with the traditional long division algorithm, much like you guys learned in elementary school, when you guys potentially learned in elementary school. And the other one is synthetic division, which kind of simplifies and is more related to matrices. All right, and I'm going to show you guys both. Now keep in mind, synthetic division only works with binomials that have a leading coefficient of 1. So x minus 5 or x plus 10, things like that. All right, so let's take a look. These are the examples from your video that did not come with the solutions afterwards. So these are the ones that you guys did on your own paper or asked to input those answers, but it didn't give you the solution. So I'm going to go over those here. All right, so we're going to start with 3x to the third plus 8x squared minus 8 divided by x plus 2. All right, so the first one I'm going to do using the long division algorithm. So I'm going to start with our division house. All right, and I got x plus 2 on the outside. So then I'm going to write my polynomial in standard form. So 3x to the third plus 8x squared. All right, but I want to make sure I include that plus 0x minus 8. I don't want to miss that place value. Just like if I was doing 3,808, I would still want to include that 0. I don't want to just type 388. All right, so we're going to go and think about, what do I need to multiply in order to make each term? So to make the first term, all right, I need to multiply x by 3x squared. So I'm going to put that over top of the x squared term, 3x squared. All right, so 3x squared times x is 3x to the third, and 3x squared times 2 is 6x squared. All right, then we're going to take that and we're going to subtract it. So 3x to the third minus 3x to the third is 0. 8x squared minus 6x squared is 2x squared. So then I'm going to bring down that 0x. All right, so what do I need to multiply x by to make 2x squared? I need to multiply that by 2x, so that's going to be plus 2x. All right, so 2x squared times x is 2x squared. 2x times 2 is 4x. So I'm going to go ahead and subtract those. So 2x squared minus 2x squared is 0. 0x plus 4x, or I'm sorry, minus 4x is negative 4x. I'm going to bring that negative 8 down. All right, so what do I need to multiply x by to make negative 4x? I need to multiply that by negative 4. All right, so negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. So now when I subtract those are the same polynomial, the same binomial, so that's going to be 0. All right, so our quotient is 3x squared plus 2x minus 4. All right, so let's take a look at example number 2. All right, so I'm going to, again, use the long division algorithm. All right, so I'm going to start, so I'm going to do y plus 3 on the outside, and under my division house, y to the fourth plus 2y to the third. I don't have y squared term, so I'm going to do plus 0y squared minus 4y plus 9. All right, so what do I need to multiply y by to get y to the fourth? So that's going to be y to the third. So y to the third times y is y to the fourth. Y to the third times 3 is 3y to the third. All right, so subtract that from my original. So that's a 0. 2y to the third minus 3y is negative y to the third. Bring down my 0y squared. All right, so what do I need to multiply y by to get negative 3y? So that's going to be negative 2y squared. So y to the third minus y squared so far So negative y squared times y is negative y to the third. 3 times negative y squared is negative 3y squared. So subtract all that. That's going to make that 0 minus negative 3 is going to be positive 3y squared. And I'm going to bring down my negative 4y. So what do I need to multiply y by to get 3y to the second? I need to multiply it by 3y. So I'm going to do plus 3y up here. All right, so that's going to be 3y squared. All right, 3y times 3 is 9, so that's plus 9y. All right, and then I'm going to put my difference up here because I kind of ran out of room here on the slide. All right, so when I do that, so negative 4 minus 9 is going to be negative 13. So negative 13y, and I'm going to bring down that plus 9. So now what I need to multiply y by to get negative 13y, I need to multiply it by negative 13. So negative 13 times y is negative 13. Y, negative 13 times 3 is negative 39. So now I'm going to subtract. All right, so 9 plus 39 is going to be 48. All right, so that's our remainder. So when we write our remainder, we just add that to the end as a fraction, 48 divided by y plus 3. So my quotient is going to be y to the third minus y squared plus 3y minus 13 plus 48 divided by y plus 3. Just like that. All right, and I know it seems a little complicated, but that's typically how we are going to write our remainders. All right, instead of using a little R notation like you may have learned back in elementary school. All right, so let's talk about synthetic division. Synthetic division is a little bit different, but it really just kind of simplifies things a little bit. And the video you guys watched kind of made that connection between the two algorithms. All right, so what I'm going to do is I'm going to, in a way, create sort of a matrix. All right, so I'm going to take this, and I usually like to augment it, so to speak. All right, I'm going to kind of create that box. All right, so I'm just going to write the coefficients. So 2x squared, so 2, 5, negative 3. And then I'm going to take this plus 3 here, and I'm going to make that a negative 3 on the outside. All right, so that 2 is going to come right on down. All right, so I'm going to take 2 and I'm going to multiply it by negative 3, so that's going to be negative 6. All right, so 5 minus 6, that's negative 1. All right, I'm going to go ahead and do that again. Negative 1 times 3, that's going to be positive 3. Add those, and that's 0. So when I factor it, all I'm going to do is I'm going to take my missing terms, which I'll do in light blue. So since I started with the highest exponent is x squared, this is going to be an x. So that's 2x minus 1. So my quotient, when I take 2x squared plus 5x minus 3 divided by x plus 3 is 2x minus 1. Just like that. All right, so now we're going to do that last example, example number 2 in the second video. All right, so let's go ahead and set that up. So I got 3x squared, it's 3x to the third plus 2x squared minus 19x plus 6. So third power, second power, first power, 0 power. All right, so I'm going to create that augmentation. And then instead of negative 3, I'm going to make that a positive 3 out here. All right, so same idea. We're going to follow that same process. 3 comes down, that's going to be a 3. So I got 3 times 3, which is 9. And because I made this the opposite, that's why we're adding these. So 2 plus 9 is 11. 11 times 3 is 33. All right, well, I got 33 minus 19. Well, let's do minus 20, so that makes it 13, but I got to add the 1 back, so that's going to be 14. All right, so 3 times 14. Let's see, 30 and 12, so that's 42, which is going to be 48. All right, so when I go to fill in those exponents, those powers, that's x squared, x, that's my constant term, and that last one is a fraction out of x minus 1. All right, so when I go to write that, and I'm going to write it down here towards the bottom, I'll do that in yellow. All right, just because I don't quite have the room up at the top this time. So that would be 3x squared plus 11x plus 14 plus 48 divided by x minus 1. And that would be your quotient for those polynomials. All right, and you can see that that whole process of the synthetic division really makes, when you're dividing by a simple binomial, much, much quicker and easier to work through.